Hi, this is Seung and I'm the director of Sky Academy, and basically what we're doing in this episode is, now that we've finished functions and relations, what I really want to do is give you a summary or like an overview of all the episodes that we've covered. Okay, so let's get stuck into it. Okay, so we've got functions and relations, and first of all what I did was started off looking at what a function is. So we looked at the various definitions of a function, and we distinguished functions, right, from relations. So remember, basically what a function is and a relation is basically a set of ordered pairs. So you might have one first element and one second element for all the different relations that you've got in a relation, right? And a relation is basically any set of ordered pairs, first element with second element. The difference between that and a function, of course, is that with a function, every first element has a unique second element. So it's a many to one relationship. Okay, whereas relations can be one to one, many to one, one to many, or many to many. Okay, and so we worked out basically how functions are different. Okay, and the way that we distinguish a function when it's depicted graphically is that it will pass the vertical line test. Do you remember that, the vertical line test? So if you run a vertical line test all the way through a graph, it should never the function should never cross that vertical line in more than one place as that vertical line moves across that function. Yes? So that's basically what functions and relations were. We also looked at the notation of functions because there's mathematical ways of communicating what a function is and what the various ways of doing that are. Okay, so after we looked at and went through the introduction to functions and relations by looking at the definitions and notations, the next thing we looked at was the idea of domain and range. And domain and range, obviously, well, if you want to watch back at that episode and become a little bit more clear with it, domain and range is basically the bandwidth of a function, either vertically or horizontally. Now, the horizontal bandwidth is called the domain. So in other words, it's all the possible x values or first element values that a function can take on. All right, so it's the set of all possible x values, whereas the range is the set of all possible y values or second elements in a function. Yes, so we worked out what the domain is and we worked out what the range is. The next thing we did was looked at the difference between odd and even functions. Now, not all functions are going to fit into the odd and even category, right? You can also have neither, neither odd, neither even, right? But let me go through what odd functions are. Odd functions essentially can be defined both algebraically and graphically as well, right? So algebraically speaking, a function will be odd if the function of any element, all right, would be the let me say it this way, all right? If f of minus a is equal to minus f of a, right, then a function will be odd, right? So in other words, the function of any element would be the negative of the function of its opposite. Okay, that's just basically the way that you can describe it, right? Whereas an even function, the function of any element, right, will be equal to the function of the opposite of that element. So f of a is equal to f of minus a, okay? And the way that works out graphically speaking is that for an odd function, you will have rotational symmetry about the origin. So in other words, if you looked at a graph, right, and you flipped it upside down, what would happen is that the graph would be exactly the same. It would map onto itself. Whereas for an even function, right, it has line symmetry about the y-axis, which means that if you have a graph, right, and basically what you did was you folded it over onto itself, the right-hand side would map onto the left-hand side and vice versa. Okay, so that's basically odd and even functions. And you could probably see then, or tell then, that most functions aren't going to be odd and even, right? Odd and even functions are actually quite a special thing, right? And the reason why they're called odd functions is because typically speaking, y is equal to x to the power of an odd number will be, would give you an odd function. Whereas y is equal to x to the power of an even number will give you an even function. And that's probably why they're called odd and even functions. Now, the next thing we did was looked at composite functions. And what composite functions are is basically a function that has more than one rule governing it, right? But the rules that govern that function will only govern it within a certain domain. Okay, so go back and have a look at that particular episode if you want to be more clear about what I mean by that. But we looked at composite functions. We also looked at combining functions, and we looked at how basically where we have two or more functions, we can combine them by either adding and subtracting, by multiplying them together, by dividing them, and we can also do this. We can put one function inside another function. Okay, so that's also what we did, and that's basically the episode of combining functions. Then we looked at different types of functions, yeah, and we looked at 6 typically that we're going to be looking at in this course. 1, 2, 3, 4, 5. The 6th one is a straight line, okay, but there's a separate unit on that. There's a separate topic on that. Okay, so basically what we did was we looked at the function of a circle, right? Now, if you are really clear about what I went through over here, you would realize that a circle actually is not a function. It's a relation, right? Because it fails the vertical line test. However, I've just put it there as functions of a circle, and the general form, or the basic form of the function of a circle is x squared plus y squared equals to r squared, okay? X squared plus y squared equals to r squared, and then we looked at different ways of expressing, say, semicircles, yeah? Now, a semicircle is just a circle expressed with x as the subject or y as the subject. Now, with circles, so for example, x is equal to one or the other, what you'll find is that you've got a plus bit and a minus bit, yeah? Now, with the plus bit and the minus bit together will make the full circle, whereas the plus bit on its own, for example, in this particular semicircle, means that you're looking at the right-hand side, or the right-hand side of the semicircle, whereas the negative would be that you're looking at the left-hand side of the semicircle, right? Whereas for y equals to plus or minus the square root of r squared minus x squared, you're looking at the top half of a semicircle and the bottom half of a semicircle, yeah? So we looked at semicircles. The other thing that we looked at was rectangular hyperbola, right? And we looked at, especially with rectangular hyperbola, we looked at special things like asymptotes, we looked at limits, and that's particularly good at helping us do that. All right. After that, we looked at different types of polynomial functions. Now, the 2 types that are going to be important here are quadratics and cubics. And we looked at quadratic functions. Basically, the highest power will be 2, right? And you've got x's going down in power with coefficients in front. Coefficients meaning numbers in front of them, right? So A, B, and C are coefficients. In other words, they're numbers. The highest power is 2, and that's what we call a quadratic, yeah? The same thing will apply, except the highest power will be 3 for a cubic, yeah? Whereas probably all that you really need to know for this course is that a cubic is y is equal to x to the power of 3, and that's the most basic cubic form, Yeah. We also looked at exponential functions. Y is equal to some number, some base to the power of x, right? And that's an exponential function. And we'll certainly be looking at that a little bit more later on down the track. Okay. And finally, what we did was we looked at regions and inequalities. Now, we did do inequalities in a previous chapter. Right, equations and inequalities was that chapter. Whereas now what we're doing is basically looking at how to represent that as a function on a number plane. Yeah, and there were a number of rules to work out how to graph an inequality. Right. So when you've got two variables, an x and a y variable, in an inequality, what you've got to do is you've got to work out the boundary first, and the boundary will be right. The equation with an equal sign as an equation rather than as an equality, and that will be your boundary. The next thing you've got to work out is whether the line is going to be dotted or the boundary is going to be dotted or unbroken. Yeah, because sometimes if you've got, for example, greater than or less than, the boundary needs to be dotted. Whereas if you've got greater than or equal to or less than or equal to, the line will be unbroken. Yeah. The next thing you've got to do is determine your region. So what you got to do is pick a point, determine your region. Yes. And it's either going to be above or below or to the left or to the right. But what you do is you pick a point, substitute the x value and the y value of that point into the inequality, and if it's true, yeah, that point will be included in the region. If it's not true, then that point that you chose to substitute in will not be part of the region. Yeah, and so that's the next thing we've got to do. The last thing that we need to consider is when you're looking at simultaneous inequalities or simultaneous regions, what you want to consider is whether you are working out the intersection or the union. If you're working out the intersection, you're looking for words like and, right? Graph the region between this inequality and this inequality. Whereas if you're considering the union, you're looking for words like or, okay? So that's basically a summary of functions and relations. I'm going to stand to the side now so you can take that in. I want to thank you for watching this whole chapter. Just remember that there are more chapters to come, but in the meantime, practice a lot of questions, and I'll see you in the next chapter. Thank you for watching.